Let's look at the answers for exam 1Y. In problem 1, we have a limit, and the limit is going to 2 in part A from the right. So if I trace along the graph on the right side, we see that we end up at y equals 3. Part B, the limit as x goes to 2 from the left. So that ends up at -5. The limit as x goes to 2 does not exist because the two one-sided limits are different. F of 2 is undefined because there is no solid dot up or down where x is equal to 2. Both of the function pieces have open holes on them, so that is not a value, and then there's no other dot anyplace else. And because of that, f is not continuous at x equals 2. And you could put down either one of these two reasons. The limit as x goes to 2 of f of x does not exist, or f of 2 is undefined. Now I accept the answer that f of 2 does not exist, but technically you'll usually see that a function value is undefined and a limit does not exist. So try to make that distinction in the future. Question 2, draw a graph of the function that meets these conditions if possible. So the first one is the limit as x goes to -5 from the right side is 6, and the limit as x goes to -5 from the left side is 6, but the function value f of -5 is 9. That is no problem. So here is -5, and the limit goes to 6 on both the left and the right, so something like that. But then the function value is 9, so we just put a solid dot up there. The open circle here indicates that there is no function value there, but the graph leads into that point from both the right side and the left side. Part B, draw a graph of the function that meets these conditions. The limit as x goes to 2 from the right side is positive infinity, the limit as x goes to 2 from the left side is negative infinity, and the limit as x goes to 2 overall is 0. Well, this one is not possible. And the reason is, you know that if you have a two-sided limit, the whole limit, the limit as x goes to 2, then that automatically implies that the limit on the left and the limit on the right are equal to each other, and they would have to be equal to whatever this limit is. Since these two one-sided limits are infinity and negative infinity and not 0, then this situation is not possible. Let's look at problems 3 through 7. These are the basic limits. Number 3, no problem here. We can just plug in the 3. And we get 21 minus 1 over 10 is 20 over 10, which is 2. Number 4, if you try to plug in 6, you get 0 on the top and the bottom. So we need to factor. So we're going to get x minus 6 and x minus 8 on the top, x minus 6 and x plus 6 on the bottom. So we try to cancel, and we can. We can cancel the x minus 6. That leaves me with the limit as x goes to 6 of x minus 8 over x plus 6. So that would be 6 minus 8 over 6 plus 6, which is -2 over 12, which is -1/6. Number 5, we want the limit as x goes to 3 from the left. So we need to interpret the absolute value bars. The top part of the fraction stays the same. But if you're going to 3 from the left, that means your values of x are less than 3. So the value of x minus 3 is a negative quantity. The absolute value bars are going to take that negative quantity, that is x minus 3, and negate it so that it then becomes positive. It's sort of the two negatives make a positive deal here. So what we have in the bottom really is a negative of x minus 3. Well, those terms, x minus 3, cancel, leaving us with the limit as x goes to 3 from the left of 1 over negative 1, which is then the limit as x goes to 3 of negative 1, and the limit of a constant is just that number, so it's negative 1. In problem 6, we have a piecewise function, and we're taking the limit as x goes to negative 2 from the left. So since this is a left-sided limit, we're going to need values that are less than the numbers. So the part of the piecewise function where x is less than the negative 2 is the bottom one. So we have the limit as x goes to negative 2 from the left of the square root of 4x plus 9, which is just the square root of 4 times negative 2 plus 9, which is the square root of negative 8 plus 9, which is the square root of 1, which is 1. Notice that the top part of the piecewise function plays no part in this problem because we are only taking the limit as x goes to negative 2 from the left, therefore requiring all the x values to be smaller than negative 2. Number 7, this is the limit as h goes to infinity, so we're basically looking for the horizontal asymptote. To find the horizontal asymptote of a rational function, you need to compare the degrees of the numerator and the denominator. But here we have that the degree of the top is less than the degree of the bottom. And when that is the case, the limit is automatically 0. Question 8. Find the intervals where q of x is equal to 12x to the 5th is continuous. Well, 12x to the 5th is polynomial, and therefore it is continuous on the entire real line. Negative infinity to infinity. Let's look at number 9. P of x is equal to x squared minus 3x minus 40 over x squared plus 7x plus 10. Find the partition points and create the sign chart. So first off, we're going to find the zeros of p, and that is found by taking the numerator and setting it equal to 0. This factors as 8 and 5 minus and plus, and that gives me x equals negative 5 and x equals 8. Next, we need to find the discontinuities. You find the discontinuities by taking the denominator and setting it equal to 0. This one factors as well, so we have x plus 5 and x plus 2. That gives us x equals negative 5 and x equals negative 2. Now, notice that I have x is equal to negative 5 in both the zeros and the discontinuities part of the solution here. One of them trumps the other one. Which one is it? Well, being a discontinuity trumps being a 0. So we actually only have one 0, and that is x equals 8, and we have two discontinuities, x equals negative 5 and x equals negative 2. Now next, let's come up with the sign chart. I'll put these three numbers on the sign chart in order. Negative 5, negative 2, and 8. I'll put above those where those came from. The negative 5 was a point of discontinuity, so that gets marked with ND. Negative 2 was a point of discontinuity, so that's also ND. ND stands for not defined. And then 8 was a 0, so we'll put that as 0 there. Then you need to test values in each of these four intervals by running those values through P of x. And when you do, you'll get a plus, plus, minus, and a plus. And so that is the sign chart for P of x. Now next, we're going to use this information to find the intervals where f of x is continuous. So please note that f of x is equal to the square root of p of x. It's the same function underneath the square root. And per our discussion in class, we talked about where the function that has a square root in it would be continuous, and that is if it's a square root, and that would be where the inside function, in other words the p of x, is positive or 0. So looking at the sign chart, I'll go ahead and graph the parts of the sign chart that are important here. It's positive from negative infinity to negative 5. Then it's undefined at negative 5, so we have an open circle there. But then we continue on from negative 5 to negative 2. Again, open circle at negative 2 because the function is undefined. We can't use the negative portion, so nothing from the middle piece here. But then we do get from 8 to infinity as being positive, and we can take the square root of 0, so we're going to use 8 as well. So every place that I've highlighted there in green form the intervals where f of x is continuous. So this would be continuous from negative infinity to negative 5, union, negative 5 to negative 2, union, 8 to infinity. And technically it includes 8 because you can take the square root of 0. I did not count off on the test if you fail to put in the square brackets, but you should put in the square brackets for the continuity on this one. Let's look at number 10. Determine where the function f of x equals x squared minus 8x over x squared minus 64 has vertical asymptotes and where it has holes. So first I'll start by factoring the numerator and the denominator. Factors as x times x minus 8 over x minus 8 times x plus 8. Now since we're looking for vertical asymptotes and holes, we need to find the discontinuities. The discontinuities occur when the denominator is equal to 0, and of course that would be x is equal to 8 and x is equal to negative 8. I'm going to start with x is equal to negative 8. Notice that the factor that gives us the discontinuity of x equals negative 8 is x plus 8. There is no x plus 8 factor in the numerator. So therefore, x is equal to negative 8 is automatically a vertical asymptote. Now let's concentrate on x equals 8. The factor that gives me x equals 8 is x minus 8. But notice that there's also an x minus 8 factor in the numerator. When you have this factor in both the numerator and the denominator, you're required to take the limit as x goes to 8 to this particular number, right, of this function and see what happens. If you get a finite number, then you have a hole. If you get does not exist or infinity or something like that, then it's a vertical asymptote. So notice we have the function. We're taking the limit as x goes to 8. We can cancel off the x minus 8 factor, and that gives me the limit as x goes to 8 of x over x plus 8, which is then 8 over 8 plus 8, which is 8 over 16, and that's a half. Oops. Since it is a finite number, that implies that we have a hole at 8, 1/2. You are required to find the y value for the hole since a hole is a point. Let's look at number 11. The first class postage costs 60 cents for the first ounce or fraction thereof, and an additional 20 cents for each ounce or fraction thereof. So write the piecewise function c of x. Alright, so all piecewise functions look like this. I have the little brace on the left side here. And the first part of the piecewise function are the values. The next part is the domain. A lot of students switch those around. You really need the domain to be on the right side. That's the standard way of writing this. And then the function values that are returned on the first part here. So the values that we're going to get here are 60 cents and that is for the first ounce. So the first ounce is from 0 to 1 ounce, and then that's the fraction thereof. So if you had half an ounce, you would still pay the 60 cents. And anything up to and including 1 ounce would still be 60 cents. As soon as you go over 1 ounce, then you add 20 cents, and that's 0.8 or 0.80 or 80 cents. And that's x is less than 1 is less than x is less than or equal to 2. And then add another 20 cents, so it's $1. 2 is less than x is less than or equal to 3, or 1.20, $1.20. 3 is less than x is less than or equal to 4. Don't forget the if keyword. Some places you'll also see the word when. You can do that, but you do need the keyword in there to be in the standard form. Sketch the graph of c of x from 0 to 4. So the first value was 60, and it's open at the left end, and then goes over, and it does include the right endpoint. Then we have 80 cents. It's open, and it goes over solid at the right endpoint there. Open, over, solid, and then open, and then solid. And those values just come from the function above. C, find the limit as x goes to 2 from the left. So you can look at the graph and see that that would be 0.8. The limit as x goes to 2 from the right. You can see that that would be $1 from the graph. And since those two values are different, the whole limit does not exist. Let's look at 12, 13, and 14. And all of these use the same function, x squared minus 13x plus 5. Question 12 was to find the slope of the secant line between the point where x is 3 and the point where x is 5. So that would be f of 5 minus f of 3 over 5 minus 3. And then using the calculator, we get these values, negative 35 minus negative 25 over 2, which is negative 10 over 2, which is negative 5. Next, I'm going to rewrite the function here so that we can see it when we scroll down. X squared minus 13x plus 5. And for 13, we need to find the derivative using the definition. So that's f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. I'm going to fill that in with our function information. So that's going to be x plus h squared minus 13 times x plus h plus 5 minus x squared minus 13x plus 5 over h. And multiply that out and distribute the negative. So it's going to be x squared plus 2xh plus h squared minus 13x minus 13h plus 5. Distribute this negative to give me negative x squared plus 13x minus 5 over h. Now what can we cancel? Well, the x squareds cancel. The negative 13x's cancel, and the 5's cancel. And that leaves me with 2xh plus h squared minus 13h over h. Let's factor out the h. So that leaves me with 2x plus an h minus 13 over h. The h's cancel, leaving me with the limit as h goes to 0 of 2x plus h minus 13. Now that we don't have a denominator, we can evaluate the limit by taking h goes to 0. And that gives me 2x minus 13. Lastly, let's find the limit. Find the slope of the tangent line of f at x equals 3. So we know that the derivative function is now 2x minus 13. And what is f prime of 3? You just plug in 3. It'll be 6 minus 13, which is negative 7. Next, question 15 was, show that the function f of x is equal to the absolute value of x is not differentiable at 0. That one's in your notes, so I'll let you look at that from your notes. And finally, number 16, sketch a graph with the following sign chart. So I'm going to try to line it up with the 0 where it should be. Now, you could have several different graphs, several different ways of handling the not defined part, whether you use holes or vertical asymptotes, it doesn't matter. I'm going to draw one here. First, we know that there's a 0 at negative 3. So there's that. And then the graph is negative on the left, hits the 0, and then is positive on the right side of negative 3. There is an undefined portion at 1, and you can handle that several ways. We can have a hole at 1, but then immediately on the right side of 1, the graph picks up in the negative range here. So then it's negative, and it just needs to stay negative throughout. If you didn't want to do that, you could have certainly put in a vertical asymptote at x equals 1 and had it sort of go up on the left side and then start on the bottom coming out. Then you just got to make sure you're negative there. So it looks something like this. So it could have been something like that for your graph if you wanted to do that. All right, thanks for watching.